Hi guys, today we're going to talk about factoring special cases. Now in the last couple lessons we have been doing some factoring, and you really can do that type of factoring with these special cases, but this is just like a little trick, I guess, or maybe a simpler way of doing a couple of the problems, as long as you recognize that they're a special case. And we're going to start off here with the perfect square trinomial, and there are two types of them. There's one with all positive, all plus signs, and then one with a minus in the middle and a plus at the end. Now the way that these work is this term and this term are both perfect squares, and this one here is going to be twice that of the first variable, and here of the second one, the a and the b. And the way that they break down is they're going to be the two quantities being the same, where you have a plus b and a plus b, and then what you're going to do is you're just going to write it as one quantity being squared. And the same thing goes down here. Both of these quantities are going to have an a minus b, and then you would just write it as a minus b squared. So let me do a couple examples and show you exactly how it works. So the first thing that you want to look at is your first term and your last term, and you want to make sure that those are both perfect squares. And what I mean by that is you can take the square root of that and actually get a number, and you can. So if you took the square root of that and the square root of that, what you would end up with is an x. Here would be a 5, and since these are both positive, this would be an x plus 5, and then another x plus 5. And if you would distribute this out, you would see that it would actually work. So x times x gives you x squared, x times 5 would give you 5x, another 5 times x would give you 5x, and then if you combine those, that would give you 10x, and then 5 and 5 give you 25. Now, if you recognize that right off the bat, all you'd have to do is take the square root of that and the square root of that, so you get an x and a 5, put a plus there, and then just do a square. So if you come down here to the second one, this is a perfect square, this is a perfect square. Now you'd have to recognize that there is a minus sign there. If you do, and you take the square root of that and the square root of that, put the minus in the middle, square it, and then that's your answer. So moving on, look at your first term, look at your second term, square root, it works. So square root of x is x, or square root of x squared is x, and the square root of 16 is 4. And I'm going to put a plus 4 because both of these are positive, and then I'm going to square it. Next one, same thing. If you look at that and look at that, those are both perfect squares. So you're going to have n, they're both positive, so plus, square root of 64 is 8, so you have n plus 8 squared. Now you won't always have a trinomial with nothing in front. You may have it with something like this in front. As long as it's a perfect square, and this is a perfect square, it should work out. Just recognize that you have a minus sign there. So square root of 9 is 3, square root of g squared is g, or square root, g squared is g, minus, and then do the square root of 4, which is 2. Now if you want to check it, just to make sure that that works out, you can do that. So if this was 2 of them, I'll just go ahead and write them both down. Show you that it works. So if you use distributive property, that'd give you 9g squared. This would give you a negative 6g. This would also give you a negative 6g. This would give you a positive 4, and then when you combine that, that would give you 12g, which is what you have right there. And the last one on the page here, this is a perfect square. That's a perfect square. Your signs are positive, so square root of that would be 2t, square root of that would be 9, and then you have two of them, two quantities. Now we also have another type of special case here, and This is called the difference of two squares. Don't need that there. So the difference of two squares looks like this. You're only going to have two terms. They're both going to be perfect squares, and you're going to have a minus sign there. If you recognize that your problem is in this form, then your answer is going to be in the form quantity a plus b and a minus b. So this is what they look like right here. Example, x squared minus 81. So I know that that is a perfect square. I have a minus sign, and I know 81 is a perfect square. So for my answer for this, you're going to have x plus 9 and x minus 9. If you would distribute this out to do a check, that would give you x squared. That would give you a negative 9x. That would give you a positive 9x. This would give you a negative 81, and you should see right here in the middle that those would cancel each other out, which is why you don't have a middle term in these type of problems. So recognize that your first number is a perfect square and your second one's a perfect square, and you have to have a minus. If there's a plus here, it doesn't work because you're not going to eliminate your middle term. So if we do the next problem here, if you take the square root of that and the square root of this, you'd have 4x plus 7 and 4x minus 7. Now if you switch these around, if you had 4x minus 7 first and 4x plus 7 second, it's the same thing. You can rearrange these, it doesn't matter, just as long as the numbers are correct and one of them is positive, one of them is negative. So either one. Same thing here, perfect square, perfect square. So you're going to have two quantities. One of them is going to be a plus, one of them is going to be a minus. Square root of 64 is 8, so you have plus 8 and minus 8. Next one, same thing, perfect square, so you're going to have x plus 6, x minus 6. And once you get to a couple of these practice problems, once you start doing them, it becomes fairly easy to recognize that they're a special case, and once you recognize that, then you don't have to really work anything out. You can just, find the square roots and then write down the answer. So another one, perfect square, so 2x, one's plus, one's minus, square root of 121, 11, and negative 11. Now the only thing that you need to worry about, and this goes for the last lesson as well, there are some times when you have to factor out the greatest common factor. Because you'll have a problem that looks like this, it looks like you should be able to do something with it, but this number here isn't a perfect square and neither is that. So if you run into something like that, you should always try and factor out greatest common factor. So when you look at this, say to yourself, okay, what could I factor out of both? Well, it looks like I could take out a 10. 10 will divide into there, leaving you with an x squared, and 10 will divide into there, which will leave you with a 4. Once you have this, 10 just comes along for the ride. This is the difference of two squares. So you're going to have x plus 2 and x minus 2. And then you look at the last one, you have 8y squared minus 50. So 8 isn't a perfect square, neither is 50. So it looks like we're going to have to factor something out. Looks like if we factor out a 2. If you take out a 2 from 8, you're going to be left with a 4. Take a 2 out of 50, you're going to be left with 25. And both of those are perfect squares. So then you're going to have two quantities. You're going to have 2y plus 5 and 2y minus 5. And there are your special cases, so you have the difference of two squares, and then you just have the perfect square trinomials. So if you recognize, if you have those, then go ahead and use these little tricks. Basically, once you have it determined that they're all perfect squares, and you can just write them down with your plus and minus, find the square root, and then you got your answer.